So I could sit here and tell you that Carl Friedrich Gauss was born in Brunswick, Germany on April 30th, 1777, or that his parents were poor, working-class laborers. Maybe even that his father didn't want him to go to school at all, and instead continue the family trade of gardening. But I'm not going to, because that's boring. Let's talk about math.
Long time ago, a young 7-year-old Gauss got into a bit of trouble with his teacher. He was told that he was both stupid and that he add the integers from 1 to 100 as a punishment. Wah, 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 wah. Now back then, there were no calculators. Anyways, young Gauss discovered that if you add the first number and the last numbers, 1 plus 100, you get 101. And if you add 2 and 99, you also get 101, and so on. This happened 50 times, so Gauss multiplied the number 101 by 50 to get the answer 5,050. After a while, Gauss's formula was simplified to the quantity of the total number of terms divided by 2 times the quantity of the first term plus the last term.
Note that this only works for arithmetic sequences. There are different ways to ask for partial sum. For example, it can be written in sigma notation. This is the Greek letter sigma, which is used to represent summation. The I is the index or starting point, and the top is the summation limit, which is the number you go to. So this equation basically asks for 1 plus 2 plus 3 plus 4 plus 5. Easy peasy, squeeze the lemon. So some guy once said that practice makes perfect. He was wrong, okay? Because perfect practice makes perfect. So let's not mess up this math problem. So let's find the sum of all the integers from 1 to 50. Now using Gauss's formula, we have 50 over 2, which makes 25 times the first term 1 plus 50 to get 1275. That math is impeccable. Did somebody say Nerd Man?
Nerd Man! Hi, I'm Nerd Man. Gauss helped a lot in solving for matrices. Despite having covered it in Chapter 7, I'm sure many of you don't know what Gaussian elimination is, let alone matrices.
Hey Nerd Man, do question number 50 for us.
Question 50, let's see.
Beep boop, beep 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 beep.
The solution is -1, 3. Now, you can easily find this solution by looking in the back of your textbook, but remember, that's cheating. I'm so quick, you may think I'm a magician, but really, I'm just a mathematician. Let's look at this problem, shall we? We have 2, 2, 6, 3. Now don't forget, it's an augmented matrix. There. So, what we want to do is we want to make every number in the main diagonal 1 and everything beneath it 0. So we can do this by dividing row 1 by 2. Which would give us pretty impressive if I do say so myself. Okay, so what do we need to do after that? Well, we need to make this guy here 0. Now you might think we need to first make this 1. However, the order is this, then this, then this. Okay? So don't be stupid. Okay? So we can make this 0 by subtracting row 2 from 2 times row 1. So here, R2 minus 2R1. And so what this gives us is 2 minus 2 is
0.
Smart. 1, 0. -3, 3. -9, 8. Whoa, whoa, whoa there! That's a negative. Don't be scared. Don't be frightened. Be enlightened. And how so? Well, multiply row 2 by negative 1/3. And you get 1, 0, 1, 3, 8, 3. No negatives. Pretty neat, am I right? And then finally, now that we have this matrix, we can set up our equation. X plus 3y equals 8, and y equals 3. Anyways, we plug in the 3 here, and we get x plus 9 equals 8, and then x equals 8 minus 9. Do you know what that is, Sonny?
-1.
Correct. Negative 1, 3.
Quick math.
See, Gaussian elimination has also been expanded to Gauss-Jordan elimination, in which these values right here are turned into zeros. And so, with maths like this, you can be a cool kid just like me.
Shut up.
Nerd man.
Any surface can be described via Gaussian curvature, being a positive, 0, or negative value. First, pick a point, any point, on the surface. Find any intrinsic symmetries and look at two perpendicular cross-sections that intersect at that point. Curves that have the same handedness are positively curved, figure A, forming domes and bowls. A sphere is likely to come to mind. Curves that oppose each other are negatively curved, B, and are usually shaped like saddles. Lastly, if two curves are perpendicular to each other, or a curve meets a line, then the curvature is 0, as is the curvature of a piece of paper. Some shapes, like the torus, or a donut, have multiple curvatures, positive on the outside, negative on the inside, and 0 along both sides. Any inelastic surface will retain its curvature regardless of its position. A piece of paper, for example, has 0 Gaussian curvature when flat and 0 curvature when bent. This is also why a sphere cannot be transformed into a plane. A plane has 0 Gaussian curvature and a sphere has positive curvature, hence a globe can never be accurately represented on a map without distortions. Depending on the surface, the distortions can be wildly different. The most common example is a triangle's angles. On a positively curved parabolic surface, the angles add up to less than 180. On a negatively curved hyperbolic surface, they add up to greater than 180. A plane that has 0 curvature will always have a sum of exactly 180 degrees.
Aside from partial sums of arithmetic series, differential geometry, and solving multivariable equations through row operations, Gauss also had a hand in statistics. However, before talking about statistics, we have to first discuss the story of Ceres, a dwarf planet discovered in 1772. Somewhere along the line, it was lost. Its orbit was undetermined. A 24-year-old Gauss would change that. In 1801, he found it once again and later published his methods in the dissertation, The Theory of the Motion of the Heavenly Bodies About the Sun in Conic Sections, aka Theoria Motus. Introduced the idea of least squares, a very important method of regression in statistics.
Least squares is a method of finding the best fitting trend to a two-variable set of data. It can be applied to a variety of correlations, but it is most applied to linear correlations. Least squares finds the best fitting trend by minimizing the sum of the square residuals. With this in mind, the steps to regression with the least squares method are as follows. 1. Find the slope of the line through n, which is the number of points, times the sum of x times y minus the sum of x times the sum of y, all over n times the sum of x squared minus the sum of the quantity of the sum of x squared. 2. Find the y-intercept of the line through the sum of y minus m times the slope times the sum of x all over n. And 3. Create the equation of the line through point-slope form, or y equals mx plus b. Using this process, let's go through an example problem step by step. In this example, we're given 10 points and we need to find the line of best fit for this set of data. But first we need to find what each of the variables are. And we're given n, and it's 10, but finding the sums are a bit more difficult. And an easy way to deal with that is by making lists in your calculator for x and y, and then finding the sums which turned out to be 55 for x, 59 for y, 381 for xy, and 349 for x squared. Next, we have to input those variables into the equation for slope, which turns out slope to be 1.215, and then after that, we have all the variables necessary to find the y-intercept, and that turns out to be negative 0.783, which makes our final equation for the line of best fit to be y is equal to 1.215x minus 0.783.
Alright, ladies and gentlemen, this is the moment you've all been waiting for, the end card, the Gauss cipher. We got the best in the biz dropping those fire beats for y'all. Starting off the cipher strong, please give your full attention to Marky B.
My boy Carl Friedrich Gauss ain't messing around. When he added numbers 1 to 100, it'll burn the place down. The teacher tried to punish him, but started a revolution. After that, the teach better use a pseudonym. This method was impeccable. I mean, it's flexible, accessible, memorable, and respectable. N over 2 times the quantity first term plus the last term. This equation's pretty firm, and we can confirm and affirm and even reaffirm. It works. These partial sums lead to faster outcomes that help you overcome math problems. And when the time comes, you'll cringe at these puns, but you're welcome. For the A on the test, you'll now get to rest. You passed this intelligence test and avoided that cardiac arrest. It can also be written in sigma notation, but you need not look to a new location for a different calibration. We got the education of application with our organization. It's the same formation of a calculation. Easy. Squeeze the lemon.
Dang, alliteration king. Yo, I need to get some lessons from my man Marky. Dang. Next on, take a cipher, gather round to give your ears some therapy with Nerd Man.
Yo, they call me Nerdman cause I got that knowledge. I'm so smart, I went to Truckee Meadows College. But before I start to brag, I have to acknowledge my main man Gauss, for which I have to give homage. Oh, they always bully me. My back is really ouch.
No, my child.
Don't give up.
You have to continue. Continue for Gauss.
I won't give up and be like the average. Whoa, look, Nerdman is turning into a sack. Starting off with finding solutions for a matrix. We be dodging all these problems like Neo in the Matrix. So how exactly does one do Gaussian elimination? All the main diagonal needs to be one, that's the location. Remember when you're doing this to use the row operations. Yo, math is cool, that's an astute observation. Don't forget back substitution for the equations. Don't be envious of my math skills, it's just God's creation.
Now that's what I like to call inspiring and introspective. Nerdman on the track, reminding the audience about what values really matter. Alright, finally we got a newcomer to the game, MC Harambe. Man, I'm not too sure about this kid.
Dunk little series like a ball, said his Carl. Gauss pitched his name to the oval cause he's so flippin' formal, acting like it's normal. For his creation, dissertation, to not even get a rep from the French nation. Least Square's method was his culmination. Some guy Legendre tried to bounce it as his own. Sit down, Legendre, you're not even Einstein. If you really want a good haircut, check out mine. Little known fact about distribution, used to be named for the place, and my man Gauss wasn't until a biostatistician wrecked the recognition. Don't even know his name, shows his place.
Alright, okay. I see you, we see you. MC Harambe, starting off his career strong. Alright, ladies and gentlemen, that's all we got for you today. I hope you have a nice one. This is DJ Gauss, out the house. Peace!